Hi everyone, welcome back to Chemistry Portal. I am Sudhanshu Kumar, and in this today lecture we are going to talk about electronic configuration of an atom. So the question is, what does electronic configuration means? So the answer is, electronic configuration, it describes us how the electrons occupy the atomic orbital inside an atom. And these all things we study in the electronic configuration, right? But before going to this topic, we have to study these three terms first. First is Pauli Exclusion Principle, Aufbau Principle, Hund's Rule. These all three terms we must have to know before going to this topic, electronic configuration. So the basic idea of electronic configuration is how the electrons, it describes the how the electron occupy the atomic orbital inside an atom. Understood? And now we will see one by one terms. First is Pauli Exclusion Principle. So first topic is our today in this lecture mainly focused on Pauli Exclusion Principle. So suppose we have here an atomic orbital. It can be any atomic orbital. It can be S, it can be P, it can be D. Understood? I have taken here atomic orbital. For suppose we have to fill the electron inside the atomic orbital. Suppose you are filling the electron like this, both in the same direction, but having a minus half, ms value minus half. And suppose if you fill all the three electrons in the one atomic orbital, or you can fill the two electrons in the atomic orbital but having a opposite spin, right? Here the two electron having a same spin, here also the two electron having a same spin but in the having a minus half, and here suppose we have filled the three electrons in the same spin, or you can fill the three electrons in the opposite spin, doesn't matter. So what does the Pauli Exclusion Principle means? What does it say? So Pauli says that an atomic orbital can accommodate a maximum of two electrons with opposite spins or paired spins. That is shown by like this. Understood? Now tell me, among these atomic orbital electron representation, which is a correct one? Read the statement. An atomic orbital can accommodate a maximum of two electron with opposite spin or paired spins. That is shown by like this. Okay, so it means this is your wrong. We cannot fill the electron like this in the atomic orbital. Okay, this is also wrong because here both the electrons having a same spin, but the Pauli said that electrons should be filled in opposite spin and maximum of two electrons in one atomic orbital. So this is also wrong. And see the third one. See here. Here in one atomic orbital we filled three electrons. That is not possible. Understood? Pauli said that an atomic orbital can accommodate a maximum of two electrons. So this is also wrong. Understood? Now see the last one, representation. Here in one atomic orbital we have filled two electrons with opposite spin. Opposite spin means one having a magnetic spin quantum number plus half and the second one is minus half. Understood? Okay, and this is shown by like this. Understood? Or we can say that here both electrons with paired spin. Okay, this representation is called paired spin or opposite spin. Understood? So this is what the Pauli said. Okay. Now, or we can say indirectly, no two electrons in an atom can have all the four quantum numbers same. Understood? We have already discussed all the four quantum number, like principal quantum number, azimuthal quantum number, magnetic quantum number, a spin quantum number. We discuss all these quantum number. Okay, all the links are given in the description box. You can go and check, right? So this statement we can say in other words, like no two electrons in an atom can have all the four quantum numbers same. So what does this mean? So let's take some example. Okay, for suppose we have 3s orbital, right? And we know that in one atomic orbital we can fill maximum 2 electron according to Pauli principle, right? So suppose first of all fill the first electron, and for the first electron we can write all the four quantum number, right or not? And because this electron is present in the third cell, it means the third quantum number, that is n equal to 3, that is called principal quantum number, that is n equal to 3, and L means azimuthal quantum number, and for the s atomic orbital, L value is given here 0, we know this, right? And the ML value, that is called magnetic quantum number, okay, and this ML value for the s orbital, it is 0, okay, and because this electron is pointing upward direction, we can say it is a plus half. Understood? That is a magnetic spin quantum number, that is a plus half. Now fill the second electron, and we know that according to Pauli we have to fill the electrons in such a way so that the two electrons with opposite spin, right? So it means we have here, now fill the second electron in the opposite spin. Okay, now write the principal quantum number for this electron, for this highlighted electron, okay, this one. So for this electron also, because this electron also is present in the third cell, that is the principal quantum number 3, so we can write here n equal to 3 and here L equal to 0 and ML value 0. Now the second electron having a opposite spin, so we can write here minus half, okay, understood? So here you can observe one thing, for this electron and for this electron, all the four quantum number are not same. Understood? No two electrons in an atom can have all the four quantum number same. Okay, means n equal to 3 3, fine, 0 0 L value, ML value 0 0, but here see, magnetic spin quantum number, it is not same for this both two electron. For this electron it is a half, for the second electron it is a minus half. It means the rule is satisfy what the Pauli said. Understood? All the four quantum number cannot same for the two electron. Okay? Understood? Any one quantum number should be different for these two electron in an atom. This is what the Pauli said. Now suppose if you want to add one more extra electron in the same 3s orbital, so what will happen? Now we will see. For suppose, now try to add the third electron in the same 3s orbital. But we know that we cannot fill more than 2 electrons in the in an atomic orbital, but I am trying to feel the third electron to see what will happen. Okay, so now suppose I feel the third electron in the same atomic orbital, okay, in the 3s, and I am showing here this electron by dot, okay, understood, and this is your third electron, right? So for the third electron, we have the same n value 3, L value 0 same, Ml value 0 same, but Ms value, magnetic quantum number, this third electron, it can come up direction or it can come in the down direction. Both are possible. Understood? Minus half also or plus half also. For suppose, if you take minus half, for instance, for some time suppose, if you take minus half for the third electron, it means electron is here like this. Understood? In that case, the third electron and the second electron, all the four quantum number become same. See, 3 3 0 0 0 0 minus half minus half. It means now the Pauli principle is violated. Understood? That's why we cannot fill more than 2 electron in an atomic orbital with opposite spin. Understood? For suppose, take this third electron in the plus half direction, means like this, pointing upward. It means the third electron now having a plus half. Now see, the third electron having a plus half will match the first electron. All the four principal quantum number are same. 3 3 0 0 0 0 plus half plus half. See, what does this mean? It means here, if you feel the more than 2 electron in an atomic orbital, then it will violate the Pauli Exclusion Principle. Understood? So this is what the Pauli said. The conclusion is an atomic orbital can accommodate a maximum of 2 electrons with opposite spin or paired spins that is shown by like this. Understood? I hope you have no doubt in this topic. If you found this video helpful, so please like, share and subscribe our channel Chemistry Portal, and you can join our Telegram groups, WhatsApp groups, Facebook groups, and you can follow us on Instagram page, that is the Portal Chemistry. And thank you everyone. Thanks everyone. Thanks again.